Well, thanks everybody for coming to see the talk. There are a couple seats in here. If people on the stairs want to filter in, it's okay with me, or stay there if you like. So today I'm going to talk to you about, well, the evolution of sexual attraction, and in particular sexual attraction to voice features. So when we talk about the evolution of anything, everybody starts their talk off with Charles Darwin. So I thought I would be remiss if I didn't do the same. So Charles Darwin, the story I want to tell you about Darwin is that we normally think of Darwin as the sort of person who thought of natural selection, right? So evolution through the processes of natural selection, these are when evolution favors traits or behaviors that enable an individual to survive to the age where they can reproduce. And while he was putting together all of his materials on natural selection, he came across this animal, the peacock. And the peacock was basically the bane of Darwin's existence until he thought of the theory of sexual selection. Darwin couldn't explain why these beautiful ornate peacock tails had evolved via natural selection, because these tails really make it such that the peacock's really not going to be able to get away from their predators as well. It's a really big advertisement to the predators that they're here. I mean, this big giant, beautiful train is hardly conspicuous. So it was really in thinking of why the animal would evolve this really elaborate trait that Darwin was able to come up with the theory of sexual selection. And if you go back into Darwin's book on sexual selection, you might find this quote that I'll read for you. It says, "Although the sounds emitted by animals of all kinds serve many purposes, a strong case can be made out that the vocal organs were primarily used and perfected in relation to propagation of the species." So what Darwin's saying here is basically that in many, many species across the animal kingdom and amongst humans as well, vocalizations are really an important part of finding a particular mate, finding out who's going to be attractive, who's going to be a good partner. And that's what we're going to focus on today, is how we can use our voices as indicators of whether or not someone may or may not be a good partner, and how we've evolved different men and women have evolved different voices. So the main question we're really going to ask today, and this is a metaphorical question, obviously, is the human voice pitch a peacock's tail? It's not, obviously, literally a peacock's tail. But nonetheless, we can ask, is it like a peacock's tail? In that, is it inheritable? Is voice pitch something that's passed down from generation to generation? Is it something that's costly to produce? Now, evolution tends to favor indicators that are costly to produce rather than things that sort of don't indicate anything and just sort of are selected for themselves. Our voices, is voice pitch used when we make our mate choice decisions? When we're trying to find our partners, is voice pitch involved in this process at all? The other question is, and this is really important for evolution, is this something easy to fake? If you can fake an indicator mechanism, then it's not really a good reliable cue to sort of your underlying quality. And I'll get into that in a little bit. And finally, of course, when we talk about evolution, we need to know, does a preference for this trait increase your reproductive success? Evolution is measured in basically the number of offspring your offspring have had, and so that's what we're going to look at the number of offspring people have had. So we have inheritability, costliness to produce, use in mate choice decisions, that it's difficult to fake, and that it increases reproductive success. So that's our theme today. We're going to try to address all of these questions. So I think first it's really important to go over the basic vocal anatomy so that you understand what I'm talking about when I talk about voice pitch, because there are a lot of different voice qualities we can think of. We can think of squeaky helium voices. We can think of low-pitched booming voices. But really these things come from different vocal organs or different parts of our vocal apparatus. So what you're looking at here is basically a cross-section through the side of someone's skull here. And most of these parts that you're seeing, this is the oral cavity, and there's also the nasal cavity as well. And those are what people refer to as the supralaryngeal vocal tract, and for brevity, people just call it the vocal tract. And if you've heard somebody inhale helium, you're hearing what it would sound like if you shrunk their vocal tract to be really, really, really small. Okay? Now, pitch of voice doesn't come from the size of this resonating chamber. It doesn't come from the size of your vocal tract. It comes from the length, the thickness, and the density and tension on the vocal cords themselves. So the vocal cords are positioned inside the larynx, which you see here. And this is a top-down view of the larynx. And basically, longer vocal cords, when at rest, longer vocal cords code for lower-pitched voices. Shorter vocal cords, when at rest, code for higher-pitched voices. And also thicker vocal cords code for lower-pitched voices, and thinner ones for higher-pitched voices. And if anybody's ever seen a guitar, this is basically how guitars work, that the thickest string produces the lowest note, the thinnest string produces the highest note. When you fret the strings, you're shortening the length of the string, and that makes higher and higher pitches as you fret it higher up on the neck of the guitar. So that's sort of how our vocal cords work. It works sort of like if you've ever stretched a rubber band. If you stretch it out, that increases the tension, and the increase of tension is what raises the pitch of the rubber band. And the same thing also can happen to our vocal cords. So anyways, that's just a little bit about vocal anatomy. So when I talk about voice pitch, it's important to note that the pitch of our voice, because it comes from the larynx, which is all cartilaginous structures except for the hyoid bone, the larynx can grow independently of the rest of the body, and it does at puberty. So there's no real relationship between how deep somebody's voice is, how low the pitch of their voice is, and how tall they are, even though people commonly make this sort of misinterpretation and commonly think it does have to do with it. So just keep that in mind as we go along. So this is a spectrogram. This is how we analyze sounds. If you look at the x-axis, you'll see time. If you look at the y-axis, you'll see the frequency. And how loud each frequency is represented by how dark the shading is on these plots. So what's really neat about voice pitch is that actually these lines are spaced exactly apart. The exact amount they're spaced apart is the pitch of the voice. So you can look that the difference between these lines on the plot are further apart. So you know that this voice, just by looking at it, this voice is higher in pitch than this voice. So I'll play you a couple samples of voices so you can get an idea of what voice pitch sounds like on its own.
A, E, I, O.
So that's just a regular voice. It's unaltered. And this is how we sort of make our stimuli for these experiments too. So what I'll do is take a voice like that, and I'll lower the pitch.
A, E, I, O.
And then you can also raise the voice pitch.
A, E, I, O.
So no surprises there. We kind of all have a sort of an idea about what pitch is like. I was telling you about the vocal tract before, and this is sort of a harder concept for most people to get, but I'll just mention it briefly. These frequencies here, called formant frequencies, are resonant frequencies of the vocal tract. Bigger vocal tracts have lower formant frequencies that are spaced closer together than big vocal tracts. Sorry, than smaller vocal tracts. So bigger vocal tracts have lower frequencies. Smaller vocal tracts will have higher frequencies. And so I'll just give you, the manipulation I've made here is a bit more subtle, so pay close attention to the differences between the voices.
A, E, I, O.
So this is just the original voice, and here's with a lowered, an enlarged vocal tract.
A, E, I, O.
And a shortened vocal tract.
A, E, I, O.
So the second one sounds like it's coming from a smaller person than the first one does, and that's basically the effect of changing the frequencies that correspond to the lengths of different vocal tracts. So that's sort of just an introduction of you know, the different voice qualities that we primarily investigate. This video came on too quickly. So I just thought to give you a sense of how voice pitch could change from well, feminine to masculine characteristics, I've made this fun video.
This video is intended to demonstrate how the voice changes from feminine characteristics to masculine characteristics.
So that's me just changing the pitch of my voice. But as I said before, you can also change the length of somebody's vocal tract, right? And if you think about it, like kids have higher pitched voices than grown-ups do. and they're a bit shorter, right? So their vocal tracts are shorter. So if we combine these two manipulations together, we can simulate what it would sound like if a child was speaking or an adult was speaking. And so that's what this next video does.
Hi, my name's David Feinberg. One thing I'm working on in the perception lab is changing the parent age of the speaker and integrating that with video.
So it also simulates hair loss over a PhD as well. We can look at these vocal frequencies as how our voices develop through ontogeny from childhood to adulthood, but they also categorize the main differences between men and women's voices. So if you look at these pictures right to left, they will correspond with the voices I'll play.
Evolution. 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 Evolution.
So basically it's just changing these two vocal qualities that can change a man's voice into a woman's voice into a man's voice. Now, obviously there are other factors that are different between men and women's voices, the way we speak, how whispery our speech is, how rough it is, but these are the two most salient qualities that we sort of know are different between men and women's voices. Sorry. So when we look at voice pitch, right, there's no real obvious reason, when we take this back to Darwin, there's no real obvious reason why men and women would have different pitched voices, no reason to help us survive, right? Men having lower pitched voices doesn't help us survive better than having higher pitched voices. In fact, it's easier to understand speech from women's voices than it is men's voices. So why do men have these deep voices? And I think the answer is because it affects these things that I've got up on the board now. It affects our reproductive success. It affects our likelihood of acquiring a mate, and that's what I'll talk to you about. So we're just going to go through this list and answer each of these questions. So is voice pitch inheritable? And the short answer is yes. Testosterone causes men's voices to drop at puberty. If you administer somebody testosterone at any point in life, their voice will also drop. If you administer somebody estrogen, it will not raise the pitch of their voice. Once vocal cords are fully grown, they're fully grown. They don't shrink without surgery. They may shed some of their material as people age, but the length of the cords, once they're fully grown, they're fully grown, unless you make them longer by administering testosterone. So testosterone is inheritable, and we know it's about 50% inheritable from same-sex parents. So therefore, voice pitch is inheritable. There are studies showing similarities between father and son's voice pitch and mother and daughter's voice pitch. And there's some other really neat studies looking at monozygotic and dizygotic twins. So this is fraternal twins and identical twins. And identical twins tend to have more similar voices than fraternal twins of the same sex. So this is some pretty good evidence that voice pitch is inheritable. Are there costs associated with a low voice pitch? So one of the fundamental themes in the evolution of sexual preferences is what's called the handicap principle. The handicap principle basically says, all else equal, if someone's surviving incurring a particular cost, say if I have a clone and my clone walks around all day long carrying a sack of bricks and can do everything that I can do while he's carrying around a sack of bricks, that would make him more attractive because he's demonstrating that he can carry around that sack of bricks where I'm just walking around without a sack of bricks. So that's basically the handicap principle in a nutshell. When we talk about the evolution of preferences for voice pitch and the development of voice pitch, we think of testosterone as the handicapping hormone. Testosterone is a pretty nasty chemical. It can suppress our immune systems. On top of suppressing our immune systems, it's also associated with risky behavior. So men with higher testosterone are more likely to do foolish things that will end up getting them killed than those with lower testosterone. So if you have a low-pitched voice, you're sort of demonstrating that your immune system was strong enough to begin with that you could withstand these sort of deleterious effects of testosterone, and you can also survive the sort of risky behavior associated with the high testosterone as well. So those are the costs associated with having low voice pitch. So really, voice pitch is sort of telling us about the underlying qualities of the individual. It's telling us about the hormonal profile of the person, whether they have high or low testosterone. Okay? Which brings us to basically the battle of the sexes. This part of the talk is where we're going to talk about the evolution of our preferences and whether or not men prefer the same things as women and women prefer the same things as men. And the reason why I call this the battle of the sexes is really because men and women are looking, in general, are looking for different things in relationship partners. Men tend to be looking for more partners, and women tend to be looking for more commitment than men are. And I guess I wanted to tell you a story that sort of highlights this sort of thing, and this is one of the more famous stories of evolution. It's called the Coolidge effect. And the story goes that these former presidents of the United States, the former president of the United States, Calvin Coolidge, and his wife were down at a farm, and they're talking to the farmer, and they're watching the chickens and the roosters basically go at it all day long. And Mrs. Coolidge says to the farmer, is that rooster having sex like multiple times a day? And the farmer goes, oh yeah, definitely that rooster is having sex multiple times per day. She goes, can you tell that to Mr. Coolidge, please? So farmer says, okay, all right, I guess I'll tell him. He's the president, but okay. So he goes over to Mr. Coolidge and goes, I'm not sure how to tell you this, but your wife asked me to tell you that this rooster is having sex multiple times per day. So Mr. Coolidge, he's a sharp guy. He goes to the farmer, is the rooster having sex with the same chicken each time? Right? And this sort of speaks to the difference in mating strategies that men and women have. So in order for men to increase their reproductive success as best they can, it's best to mate with as many females as possible because sperm are cheap and easy to produce. You can produce millions of sperm a day and inseminate, let's say, hundreds of women in a day if you should so desire. Women, on the other hand, are limited in the number of offspring they can reproduce, right? It's about 1 per year. And in traditional societies, it's closer to 1 every 3 or 4 years. In traditional societies, basically, the amount of time people spend breastfeeding is quite a lot longer than here. And so we think that while we were evolving, it's likely that we were having offspring maybe once every 3 or 4 years also. So when we think about the differences in what's best for the goose or the gander in terms of increasing their reproductive success, men sort of don't have to be as choosy as women because women's eggs are quite precious and they can't waste them on bad mating opportunities. And so we're going to look at how that's reflected in people's preferences for voices. So a typical experiment we'll do, we'll take the same types of voices that I played you in the beginning that were singing A, E, I, O, U. We also have done this using sentences. We've done backwards speech. We've done tons of different types of speech. But the key feature in all of these experiments is that we're manipulating only the pitch of someone's voice. And we leave everything else in the voice as constant. So we leave the amplitude constant. We leave how the length of time is constant. And the only thing we're doing is comparing the same voice, everything's the same, with itself, and just asking people to say which they find more attractive. And so the first experiment I did with this, basically, all we did was play those series of voices for, I think, about 70 women. And these are some of the results summed up right here. Basically, on average, women were more attracted to the voices we lowered than to the voices we raised in pitch. It turns out that also women find these voices more masculine sounding, more dominant sounding. They sound larger, right? But they don't necessarily come from larger people, like I was saying. They sound older and they sound healthier. And so, in general, what we find is that women prefer men with lower pitch voices to men with higher pitch voices. These results have been replicated at least 5 or 6 different times with correlational methodologies and as well as with our manipulations. So they're quite robust. Actually, I've done this with a sample now of 10,000 people. Please just save your questions to the end, please. Thanks. So that's our work on women's preferences for men's voices. Now, when we look at men's preferences for women's voices, this graph is slightly different than the last graph. On the last graph, we basically just had high pitch versus low pitch, or low pitch versus high pitch. This has basically collapsed that into one bar. And what we've done is we've taken women's voices that start out high, those that start out average, and those that start out low, and measure how much raising the voice pitch contributes to the attractiveness ratings. And it turns out that the lower the voice is starting out, the more making it higher matters, right? If it's always high, if it's already high, making it even higher brings you diminished returns. And so that's what this graph is showing. But what's really important to note here is that this line is 50% at the very bottom. All of these preferences are men are preferring higher pitched women's voices in all of these different cases. And we also find that men and women both think that they sound more feminine, they sound younger, and they sound healthier than the lower pitched voices. It's usually at this point of the talk, or at the end of the talk, that an audience member, usually female, will raise their hand and say, I don't like high-pitched women's voices. And so I've got a slide about that, just to sort of preempt it. We also measure women's preferences for women's voices. And these are heterosexual women. And the people in the audience who ask these questions are, generally correct. Women don't prefer really, really high-pitched women's voices, but men do. And so that's our first sex difference of the evening, of the afternoon. Women are preferring higher than average men's voices, women's voices, but they're not preferring women's voices that are really, really high and squeaky. So hopefully that will address that issue. Okay, so this comes to our next sort of question, right? We can all fake our voice pitch, right? This isn't rocket science. We've all heard people sing before. And that is conscious modulation of someone's voice pitch, right? So like I was saying in the beginning, if voice pitch is supposed to indicate how much testosterone somebody has, and we can change our voice pitch, how does evolution deal with this problem that not all the time we're talking, we're demonstrating a real link between our voice pitch and our underlying testosterone levels? Well, there's a couple of answers that we can sort of try to give for this. And the first explanation I have for this, I stole from this guy, Bob Marley, who actually stole this from P.T. Barnum. And he basically says, you can fool people sometimes. Okay, so you can fool some people sometimes, but you can't fool all the people all the time. And what do I mean by this? If I was trying to attract a mate using a really lower pitched voice than I normally speak with, I would have to go around talking like this all of the time. I would have to go to the bar and talk to women like this, and then after leaving the bar, I would have to go home and try to seduce a woman with this voice. So you see why faking it doesn't necessarily work. I mean, we know we can fake it, but it just sounds ridiculous. Okay? And we are actually doing studies at the moment to try to find out in a laboratory situation the extent to which this really happens. But there are other checks and balances that evolution has given us to sort of make up for the fact that we can sort of fake our voices a little bit, right? Because it's easy. It might sound ridiculous when I lower my voice this way, but if women are raising their voices a little bit, it might not sound as ridiculous. So we've done some studies to try to address this. The first one was measuring how what we're looking at here is, well, it's a face. And facial masculinity is also related to how much testosterone people have at puberty. So if people have a lot of testosterone at puberty, it's going to make their faces more masculine. So it stands to reason that there might be some sort of correlation between how masculine someone's face looks and how masculine their voice sounds, or how low their voice pitch is, right? So evolution typically will, selection will, yes. Multiple traits that have the same underlying qualities will often be selected for. So evolution will favor many different traits that indicate testosterone just in case you can fake one of these traits. So we can sometimes fake our voices, but can we fake our voices and our faces and our smells and our body shapes all the time? Probably not. It's quite difficult to do. And so our first investigation into this was just looking at a correlation between facial and vocal masculinity. So these points on the face we can sort of amalgamate. We can measure the sort of eyebrow height somebody has, so how thick their brow ridges are. We can measure how square their jaws are, how high their cheekbones are. And these are facial traits that vary between men and women. And we can sort of make an amalgamation of these different measurements and give it an index of masculinity. And it turns out this correlates strongly with voice pitch in two different populations at about the same strength. So people with masculine voices tend to have masculine faces. So if you're faking your voice, you got to fake your face as well, right? It gets more and more complicated the more traits that are intercorrelated like this. So at this point, I want to explain to everyone a little bit about how we morph faces, because I also work on faces a lot. And one of the things we can do with faces is average different groups of faces together. And when you average different groups of faces together, what tends to happen is you highlight the sort of common qualities within that group, and it sort of washes away the differences in the faces in those groups. So when we average faces, basically we make an outline of the face. We demarcate something around 200 points on the face, and we use these to create a map of basically triangular tessellations that we can warp faces into different shapes. So first thing we do is we demarcate the faces. Then we create an average shape from those different delineation points. From there, what we do is we warp the people's faces into that shape, right? So we just basically, we scrunch everybody's face into that average shape, and then we can average the color and the texture and of each different pixel or different pixel locations to create an average face. So what would happen if we made a face average of people with low-pitched voices and people with high-pitched voices? So my question to the audience, and I always like to do a little audience participation, these are two different populations, the top and the bottom. So we're not going to do a comparison of top to bottom. I'll tell you right away, it's Canada versus the UK, so you can feel happy about Canada. The real comparison, I want a show of hands. Who thinks that the faces on the left are more attractive than the faces on the right? So do the thousands of other people we tested in our experiment. The faces on the left, sorry, the faces on the left are averages of women with high-pitched voices, and the faces on your right are the averages of faces of women with of low-pitched voices. So you can see that there's differences in the cheekbones, in the lip size, and the eye size between women who have high and low-pitched voices, and these are consistent across different populations. We've replicated this experiment using natural faces that we haven't morphed together, and we find the same exact result. So now we're in two different countries with two different methods, finding the same thing, that people find that women with high-pitched voices have more attractive faces than women with low-pitched voices do. So it's quite difficult to sort of imagine how we could walk around faking all of these different traits all of the time, right? We can fake some of them, but not all of them all of the time. So when we look at women's preferences for men, different things tend to happen than we look at men's preferences for women. Now, there's more agreement on what's attractive when men are looking at women or listening to women's voices. Men agree more than women agree about men. And I'm going to talk about that in a little bit. But because we don't always find that women like masculine or feminine faces, some studies say masculine, some studies say feminine, some say average. It really depends on the population you're looking at. We thought of going about these experiments a different way. And the way we thought to look at these experiments is, do people who like masculine men's faces also like masculine men's voices? Because there's variation in absolute preference level, we can look at this on a sort of sliding scale, right? And it turns out that women who prefer masculine men's voices also prefer masculine men's faces. It also works when you delete that tiny point at the bottom left. Check that out, don't worry. It turns out that women who prefer masculine faces also prefer masculine male pheromones. We were doing some research on pigs. We're reading about how pig farmers will get their pigs to mate, and basically what they do, they have this pheromone. It's an androstenedione derivative, basically, and in humans we call it a putative pheromone because people like to argue whether it's a real pheromone or not. I don't really want to argue, so I call it a putative pheromone. Turns out that this chemical that humans produce, this androstenedione pheromone, is the same thing that pig farmers will use to try to get the male pig to mount the female pig. They spray it on the female pig, everybody gets excited, and the pigs mate. It doesn't work that way in humans. I've tried it. The way this works in humans is these chemicals tend to have the odor of a men's locker room. They smell like a toilet, basically. So you'll often see advertisements for colognes and things that have pheromones in it. Stay away. They don't actually do what they say they do. But it turns out that, well, if you look, like most people dislike the smell of these things, right? But what you're looking at here is the sort of basic preference for facial masculinity is linked to how much they like these masculine male pheromones, right? So people who dislike these pheromones less like masculine faces more. So we see the same sort of thing with voices and faces as we do with faces and pheromones. So this is really important because if we can fake our voice pitch, we can't fake our facial masculinity and our pheromones and this and that, you know. So that's the story, is we can't fake everything all of the time, even if we can fake something sometimes. So, like I was saying, not all women are preferring these masculine men's voices, right? So the question is, why? Why don't women like all these masculine men's voices? If they indicate testosterone, and that tells us that this individual is going to be healthy and that they're going to breed offspring that can survive to reproduce, why prefer feminine men? And remember I was saying that women are typically looking for more commitment than are men. Well, it turns out that masculine men, while they have this high testosterone load that shows that they have these good immune systems and that they might have dominant offspring who could survive to reproduce, they don't stick around in relationships. They're more likely to leave their partners. They're less likely to invest monetarily and invest with their time in the offspring. So it turns out that there might be situations where women would prefer commitment over these genes for immunocompetence and dominance. There might be times where they might prefer dominance and immunocompetence to commitment. And so it's basically, it's more or less a trade-off. It's not a binary system. It's not one or the other always. But on a sort of sliding scale, this tends to work out. So basically what we have is women think that people with these traits that indicate high testosterone are worse fathers. They think that they're dishonest. They think they're less trustworthy. They think they're emotionally cold and cut off. And it turns out there have been a number of studies cross-culturally that look at men's testosterone levels, and men's testosterone levels negatively correlate with the amount that they invest in relationships and offspring. So, what's a woman to do? Basically, we have a trade-off here. And in some situations, when looking for a long-term partner, when looking for commitment, for someone to invest, it's good to go for the sort of David Schwimmer, sort of more feminine male, right? The men who are more likely to exhibit pro-social behavior, who are more likely to invest in their relationships and offspring. And at other times, you might prefer the governator, who has a likelihood of being back, but not necessarily to raise the children. He might be sent back in time to eliminate them. So, so basically, when women are preferring cues to healthier and more dominant offspring, they might prefer these masculine features, and at times where commitment might be more important, they'll prefer more feminine features. And what I've sort of done in my research is try to investigate what are these times and when do these things sort of happen. Well, one of the more famous examples of when women might prefer more feminine faces and voices is at the least fertile menstrual cycle phases. And originally it was thought that it was an enhanced preference for masculinity at around ovulation. And this enhanced preference for masculinity at ovulation was such that partnered women could go find a more masculine partner than they're with. So they could go get his genes and get them raised by their feminine husbands. I've tried to put a nicer spin on this story by saying that, that these are enhanced preferences for femininity at the time when conception is least likely, because at the time when conception is least likely is at the luteal menstrual cycle phase, which is characterized by, a spike in progesterone. It turns out progesterone is also implicated in early pregnancy and in hormonal contraceptive use. And so the body thinks basically that it's pregnant at these times, so indicators that someone might be more committed might be preferred at these times when commitment's more important. So at one menstrual cycle phase, sort of prefer these more masculine sort of voices, right? And then at other menstrual cycle phases, when people are less fertile, they might prefer some of your more feminine voices. Well, voices that I think are a bit more feminine, at least. So there's menstrual cycle, right? It turns out that breastfeeding also is implicated in the amount of masculinity people prefer. Now, remember, we're talking about times when people might need a little extra resources. And breastfeeding is one of these times. So a collaborator of mine, Karan Apicella, went out to Tanzania to study the Hadza. The Hadza are one of the last hunter-gatherer tribes alive. There are very few people who just hunt and gather for their means of subsistence, and the Hadza are a group of people who are among them. And what this means is they have no access to modern medical care. They have no access to birth control. They have no access to hospital facilities or pregnancy tests or anything like that. So there's no baby formula. Every woman who has a baby is breastfeeding or has a wet nurse doing it, but it's usually their own. What we did was we took our voice preference test out to the Hadza, and it's the same one we give people here at McMaster. It's the same one we've given at St. Andrews in Scotland and at Harvard University. And basically, we asked them, what do you prefer, the high-pitched or the low-pitched version? We have them use their own voices, and we had them listen to Scottish voices as well, and didn't find any differences in their preferences. Basically, in general, women had no preference for high or low-pitched men's voices. Women who were breastfeeding preferred feminine voices, and women who weren't breastfeeding preferred masculine, low-pitched voices. Now, we don't know if it's the breastfeeding itself that's causing these changes in behavior. It could be the recency of just having had a child. It could be sort of the psychological, I know that I'm carrying around this child, and I know I need extra resources, so I could use a hand. It might be a lot of these different things. It's unlikely we're going to be able to go back and test these things because the Tanzanian government's in the process of claiming that land from the Hadza. So we're very fortunate to have been able to do these studies, and it seems like these might be some of the last studies on these hunter-gatherer populations. So we'll talk a bit more about the Hadza at the very end. The next part of the story is hormonal contraceptive use. Now, like I was saying before, progesterone is a major component in most hormonal contraceptives. There are some estrogen-only pills out there. There are some other hormonal contraceptives that lack progesterone, but I think the figures are in the 90-something% of birth control pills contain high amounts of progesterone. And what the progesterone does is tells the body that you're basically chemically pregnant. And when pregnant, you might need some extra resources. There's a number of different different factors that go into this, but basically, you're growing a child inside of you, so you need extra nutrition to feed that child. Now, of course, in modern society, people are doing wonderful jobs of raising children without partners, but it always helps to have somebody around who can help out. And so at times when women are on hormonal contraceptives, they tend to prefer these more feminine-voiced men and feminine-faced men than at other times when women are not using hormonal contraceptives. So that's the story there. And we have one more sort of major factor contributing to individual differences in preferences, and this is how attractive women think they are. Now, I was telling you, masculine men don't commit to the relationships and their offspring, and feminine men do. There are certain times when masculine men will invest in their offspring and invest in the relationships, and these tend to be characterized by how attractive their partners are. So men with highly attractive partners are more likely to stick around and invest. Because think about it, the payoff for desertion is a lot lower if the females you're going to mate with aren't as of high quality as the one you're already with, right? So that's basically how this sort of thing works, is that women who think they're more attractive tend to prefer masculine men's voices more than women who think they're less attractive. So that sort of explains a lot of the differences we find in women's preferences for men's voices. I'm not going to show you any data today on variation in men's preferences for women's voices. I will tell you that it exists. There's not as much variation as when women are listening to men's voices, but there is a lot of variation in men's preferences. But it's too bleeding edge to let you know right now. So this brings us to this sort of final point of the talk, which is, does voice pitch have anything to do with reproductive success, right? Because we're talking about evolution here, and if voice pitch is, if the differences in men and women's voices evolve due to the processes of sexual selection, then we would expect that men with lower pitched voices would have more offspring than men with higher pitched voices would. And it turns out, when we went out to Tanzania to study the Hadza, we found that, when we corrected for how old people are, if you think about it, older people more likely to have more children than younger people, right? So we have to factor that out of the equation. So when we factored that out of the equation, we found that men with lower pitched voices had more babies than those who had higher pitched voices. And it wasn't just the number of babies they had. It was the number of babies that they had that were still alive. So it was both the number that they had produced, but also the amount that had survived up until the point of testing. So it's really interesting that, in fact, voice pitch is basically implicated in basically what we're finding is that evolution probably has favored women's preferences for low-pitched voices amongst men and men's preferences for high-pitched voices amongst women. And if this was happening to our ancestors, thousands and thousands of years ago, this could be the reason why men and women have different pitched voices today. Of course, the research is never going to be finished, and we're never going to know the final answer unless someone from physics has built a time machine. No? Okay. So unless that's happened, we're never going to really be 100% sure, but this is our best stab at it, and this is our best evidence of why men and women have different pitched voices. It's inheritable. We can inherit our voice pitch. It's inheritable from same-sex parents more than opposite-sex parents. It's costly to produce. Having a high testosterone level comes at a cost. It's used in mate choice decisions. This is a red deer. Red deer also use their voices a lot in mate choice decisions. It's difficult to fake. It's difficult to fake a low voice pitch enough so that it would lead to a copulation, for sure. And it definitely does relate to reproductive success. So I thank you all for your time, and if you have any questions, feel free.